Thank you for joining me on the final day of Dreamforce. I'm really excited to share this session on code quality and migrating to Salesforce DX. Before we begin, just a quick note that when considering future developments, whether by us or by any other solution provider, you should always base your purchasing decisions on what is currently available. My name is Blake Rosendahl. I'm a senior software engineer at Conga, and I work on the Conga Orchestrate team. And so I really have a passion for creating process that isn't going to slow your team down, but also makes benefits on your quality and your speed. During this session, I'll take you through the journey migrating to Salesforce DX that we did and provide you some foundational building blocks to improve your quality when writing and reviewing code. Salesforce DX was released around the time that we were really needing it. So we were adding developers to multiple projects and starting to work on those projects simultaneously. And so that provided a perfect opportunity for us to jump into using Scratch orgs and getting some very good version control. So how many people use Salesforce DX right now? All right, that's a few. Good. So our original development environment was in one package org where we were kind of simultaneously working in the developer console, trying to make sure that we weren't stepping on each other's toes and making it all work at the same time. And our backup system, we basically had version control to a checkpoint type, where we would pull down the code every week, every day, depending on if we made lots of big changes, just to make sure that we didn't blow up everything and had nowhere else to go. And as I was saying, we were adding developers, and so that was adding some difficulty to trying to work together, not break things that other people were working on, stepping on each other's toes. One common question in the office was, can you comment some stuff out here? Because we need to package quick, and then we can get testing. So our current process was making do, but it was showing signs of strain and ways that we could improve. And so that's where we put Salesforce DX into action. So migrating to Salesforce DX is a fairly straightforward process, and one that I recommend any developing shop that works on Salesforce explore. By using Salesforce DX, you unlock easier ways to control your code, get access to quick instances of new orgs and clean orgs, and automate your processes. So first of all, for those of you who don't know what Salesforce DX is the new developer experience where you are enabled to use source-driven version control to really gain control of your code outside of a Salesforce org. It enables fast creation of disposable orgs called Scratch orgs. And I'll get to that in just a minute. So our migration consisted of authenticating into a dev hub, and that basically allowed us to create Scratch orgs from the Salesforce CLI very quickly. And then we were able to pull that code from our package org and convert it into a Salesforce DX project, which gave us the ability to then push that code into a repo like Bitbucket, and then deploy it to a new Scratch org and start developing immediately. So the process, once we massaged all of the different components out of our package org, we were able to really get going. And we got access to a great library of scripts that we put together, including automation for pipeline building for Bitbucket, as well as a script that we put together that would create the Scratch org, install any necessary packages we need, push the code, apply permission sets, and open the org, all with one command. It makes it a lot simpler for our developers to spin up a new Scratch org whenever they need one. So there are many great Salesforce resources about migrating to DX. So make sure, if you're interested in more of those, to check out the Salesforce developer blog, Trailhead, or the Salesforce developer community to learn more. So once we migrated to Salesforce DX, we had access to a lot of different tools, and we started seeing the benefits almost immediately. For one, we had scratch orgs, and so we could all work as developers independently of each other, breaking as much as we want to get what we needed done and not impede anything else that other people are doing, which was huge. We were able to do more version control, so we were able to branch off for new features and bugs without working in the master branch. We were given access to expanded development tools like VS Code, as well as the extensions Salesforce has put together for VS Code, like text highlighting, text completion, and the Apex replay debugger. And we, as I said before, utilize simple scripting to get some of the more memory-intensive, labor-intensive setup of our orgs into one simple script. So after migrating to Salesforce DX, gone were many of the restrictions that we were facing when we were developing in one org. We were able to stay out of each other's ways when working on groundbreaking features, easily control our code versions, and take advantage of the new continuous integration options that we didn't otherwise easily have access to before. So once we completed our transition to Salesforce DX, we changed our focus to quality standards. Writing quality code can be an elusive goal. First, we need to understand the why of writing quality code. So there are four kind of main ideas that I've identified for writing quality code. One of them is technical debt. Now, technical debt, defined by the Agile Alliance, is a deficit of code quality that builds up over time. And that's either intentional or unintentional. You may be pushed for a deadline and decide something just needs to get done, and we just need to push it out and be done with it and worry about the consequences later. That is probably an unintentional or an intentional deficit in quality. Maybe you didn't know something that you now know, and that's an unintentional deficit in code quality. And so with technical debt, that's going to increase your difficulty in writing new features and fixing bugs, because you're going to have a learning curve to come up on those different designs and standards that maybe weren't there in the past. And like financial debt, managing technical debt has interest, and it can overwhelm you if you're not careful. Another important component to writing quality code is velocity. So when you have a lot of code and it's messy and it's difficult to read, and maybe you didn't even write it, it's hard to get up on that learning curve and start writing new features. And so by maintaining that quality, you're able to look into a class and say, I know exactly what's going on within the first 5 minutes of looking at it. And team morale is another big one. So specifically with our team, a lot of the business logic that we deal with was in one class. And so that obviously made a big class with a lot of moving parts. And so, especially in the beginning, some of the developers, including myself, looked at that class and said, well, I don't want to touch that. That's scary. And we broke stuff by working in that. But that's how it works. And so by increasing our quality and understanding, putting these foundational code quality items in place, we were able to start to piece out that class and really understand the certain components and make them one method, one job type of patterns. Also, you have stakeholder satisfaction to consider when writing quality code. Your customers don't like to find bugs, and they like to work with new features. Same with sales, management, and marketing. They love seeing new features, and if you're saying, well, half this focus period is devoted to bugs, they're going to kind of be looking at their watch saying, well, when are you going to give me new features? So writing quality code is critical to long-term success. So we need to plot out some first steps in that journey. So I've identified four foundational items that we used to build our set of standards for code quality. And I want to note that our standards are not to create a competition where, who can write the least amount of code. Rather, it's writing code so that we can easily read, maintain, and expand the functionality. And this requires buy-in from the whole team, I would mention. This requires managers and all team members to just be gung-ho and ready to go. And so I want to, do a quick shout out to the Conga Orchestrate team for being so on board with getting into the code standards and really wanting to increase quality of code. So I want to start with talking about incremental improvement when you're talking about quality standards. So there's the total rewrite, and then there's the we're going to refactor as we go. And our team decided that the refactor as we go with incremental improvement was the way to go. Because as a small team, we can't split our forces and say, we're going to rewrite the entire product with these 3 people and keep going with these 2 people and stay competitive in the marketplace. So the first standard I have highlighted here is methods have one job. So this method right here I have on the slide, it just is one query, and that's all it does. There's no unanticipated consequences. There's no if small edge case, then do this. It's self-explanatory. It reads itself. The second point, names are descriptive. So this method is named query active accounts by ID. So you could look at this in the code and not even have to go to the file that this method is located in to know what it's doing. And so if you're just kind of running through a method to debug quickly and you're trying to understand what's going on, you're going to have a very good idea of what's going on if all of your method names and variable names are named accurately and descriptively. We also like to utilize named constants. So that gives us context in our code. So we're able to say, oh, what's this 1 mean? It's in our constants, but it's named in our classes. And so we don't have to ever ask, well, what does this variable equals 1 mean? Or 2 or 3? We can just look at the constant name. And finally, we're trying to work to abide by the Boy Scout rule, which is leave the campground cleaner than you found it. Which is really important because as part of incremental improvement, you can't just go and trash a whole class and rebuild it. You're going to be taking time whenever you're in that class and building features to just tweak variable names to make them more descriptive, or just pull small pieces of functionality out of a large class to increase the ability to abide by that one pattern, or one method, one job pattern, so that you can more easily understand the code that you're looking at. Teamwork is an important aspect of development, which is why we use checklists and reviews as well. So checklists help us remember, and they help us reduce mistakes. And I'll give you one example. There's a surgeon and author of the Checklist Manifesto by the name of Atul Gawande. And in an interview with NPR, he was stating that when he implemented a checklist, just a simple checklist to make sure everything was all right, in the operating rooms of 8 area hospitals, he found massive results. And one of them being that when they had a checklist that simply had the team introduce themselves very quickly before a procedure, the amount of deaths and complications due to surgery fell by 35%. And that's incredible, especially when you're talking about the medical industry. And we can take that and apply that to development, because every time we deploy something, we'll inevitably forget a test or a fringe case, or just thinking about one use case that we never would have thought of. And if we have a checklist to reinforce that, we can make sure that we hit everything that we want to. And so some of the highlights from our checklist, we have 2 stages. There's a self-check, which is kind of looking over the tests, making sure they all run, making sure that your code coverage is over 75% for Apex, and making sure that your logging and commented code is removed so that it's easier to read and you don't have to sift through all the comments. We also have a review component. So that's where the author of the code and another developer go into the conference room and they say, all right, let's look at this. Let's do a demo of the new feature or the bug that we are fixing. And then let's do a walkthrough of the code and just understand what's going on in the code and look for both quality and understandability. And I should say about these reviews, it's a discussion and not a lecture. And so everybody needs to be on the same page as far as applying constructive feedback, receiving constructive feedback, and working together to make sure that we both, the reviewer and the author, increase their knowledge and grow as a team. So, in summary, migrating to Salesforce DX is a great way to increase your ability to create quality products and keep from stepping on each other's toes when you are developing. You're given a host of tools that allow you to more easily control your code, quickly create clean developments like Salesforce or with Scratch orgs that will keep you from having unanticipated consequences when you're writing, and help you automate your processes with the Salesforce CLI. Also, putting together quality standards and a process for reviews will help you pay back technical debt, increase morale, and build fantastic functionality more efficiently. With that, if there are any questions, I think I have 3 minutes. Otherwise, if we run out of time, I'll be in the back and take questions. Thank you for joining me today, and enjoy your time at Dreamforce.